here in system operations, our main function is to monitor and control the overall electric grid, as well as the distribution system for Valley Electric. So we have both transmission and distribution. We watch a bunch of computer screens where we're receiving information from substations, other entities that we're connected to. We're looking for anomalies to occur in those, and when we see those, we need to answer why those are occurring. If it's something that's expected, or if it's something that indicates that there might be a problem showing up on the system, and then we mitigate that by either taking action, adjusting stuff that we have the ability to do through a computer system, or dispatching people to substations or various areas on the transmission line, and doing whatever needs to occur to keep those anomalies or those problems from turning into something big. It's real-time data that's coming from the meter level on the home. So we're looking at information from the meter level at the home all the way to the sometimes the generation facility. So it includes the entire distribution system and the transmission system.
So the transmission system is kind of what it sounds like. It's the main bulk of power that gets transported across, I guess, the backbone of the power grid. And then from that it goes to a substation where it's stepped down to a usable voltage for the members. So all of the transformer cans outside of everyone's house, that's going to be the distribution system. That goes to everybody's house. So it's separated in the fact that it has different outage severities. So if we have a transmission outage, it's going to likely be more severe than a distribution system outage. If it's a very severe transmission system outage, it could encompass a lot of distribution that's out. A bad enough one could see the entire Plum Valley out for a transmission system, whereas distribution system, you could see anywhere between 10 to a few hundred people, or even 1,000 people, depending on if it's a feeder breaker that opened at a substation or a field recloser that opened up.
Yeah, so I'll start with behind me we have our SCADA system. That's SCADA stands for Supervisory Control and Data Acquisition. And that is a computer program that talks to all of our different substations, all of our equipment that's in the field, and we're able to monitor everything that's going on with that equipment and those devices. So we can see our voltage, how much power we're using, if people are using a lot of power, if it's a hot day, people's air conditioning are on, or if it's a nice day out and there's not a lot of power being used, we can monitor that. And we can make adjustments to the equipment to make sure that the power is delivered reliability to all of our members. And we communicate with other entities next to us like NV Energy and Southern Cal Edison. We have interconnections on our transmission system, so we do have to coordinate with entities in other states even. So everybody's power grid is reliable, and power and the lights on is for the power and the lights are on for everybody. So that's what we use SCADA for. It's very it responds quickly to alarming when something does go wrong, and we're able to get on it and send a crew out to go investigate and troubleshoot the problem and whatnot.
It's a lot of studying and understanding how your system can affect the interconnections throughout the United States. So for us, it's the Western interconnection, so California, Oregon, Washington. So that's why when we see alerts and stuff from California, we have to be ready to react, because with the fires and stuff that California sees, it creates constraints on the interconnection that we have to be prepared to react to.